Welcome to lesson 1.2 about algebraic expressions. To start this lesson, we are going to go over a few key terms. So the first key term we need to know is variable. And a variable is a symbol, usually a letter, that represents one or more numbers. So this would be something like if we had 7x plus 3, this right here would be our variable. Next, we have an algebraic expression, and this is an expression that contains one or more variables. So this 7x plus 3 up here, this is an example of an algebraic expression because it has one variable. It could also be something like 7x plus 3y, and it has more than one variable. So as long as there's one variable, it's an algebraic expression. And then we need to know this word evaluate. So evaluating means that we're going to substitute in numbers for variables in an expression. So it would be like taking this expression here and saying, okay, now I'm going to let x equal 2 and y equal 1. And I'm going to actually take that value and substitute it directly in to the variable and then simplify from there. And it's important to note that evaluate is different than solve. Solve is for when there's an equation, and to have an equation, we'll talk about this more in the next unit, there has to be an equal sign. So there's not really going to be any equal signs with our expressions here. So here we have an example. Evaluate the algebraic expression 2x squared plus 3y minus 5x for x equals -3 and y equals 2. Now, different people have their different methods for making sure that they move things properly. My two things that I do are, I use different colors or lines. Use different, usually, especially in this scenario, it's easy to use different colors. And I'll show you what I mean by lines. The other thing that I can do, or that I really, really want you to get in the habit of doing, is to use parentheses. This one is the most important thing here. And you'll see why. So I'm going to say that x, actually since I wrote that in red, let me use a different color. All right, so we'll say x equals -3 is represented by green, and y equals 2 is represented by purple. I'm also going to show you the line thing. So I could use a different kind of line for y to show that it's something different. So anywhere there's a y, I'm going to plug in a 2 or substitute in a 2. And anywhere there's an x, I'm going to substitute in -3. Sorry, I used the wrong line. There we go. So my equation is going to look like this. 2. And then I get to an x. So I write everything the way that it is written up here, but I'm going to stop when I get to that x and put a set of parentheses. Sorry. And then I'm going to continue. So that squared is still there, and then I have plus 3, and then I get to another variable, so I put a set of parentheses. Minus 5, and then a set of parentheses. So basically, I'm just taking out the x's and y's and putting in parentheses. And now I'm going to go back and fill in my values. So for x, I have -3. And I had another one over here. So that should be all of them. I can either say I've taken care of all the green, or I've got both straight lines, whatever's easier for you. And then for the y, I used purple or a squiggle. So I'm going to put a 2 where the y went. Now I can simplify, and I'm going to use my order of operations. So remember that's PEMDAS, please excuse my dear Aunt Sally, whatever you want to call it. So the first thing is anything in parentheses. I have things in parentheses, but they are already simplified. Next, I have exponent, so I'm good with that. Next, I've got exponent. So I'm going to take care of this exponent. -3 squared is -3 times -3, so that would give me 9. But then everything else stays the same. I'm going to go back to just using one color because I don't think I need to keep showing that. Then I take care of multiplication and division. In order from left to right. So multiplying these gives me 18. 3 times 2 gives me 6. And 5 times 3 gives me 15. Notice that I just brought the plus sign straight down and the minus sign straight down. So now I take care of addition and subtraction. So 18 plus 6 is 24. And then 24 minus 15 is 9. So when I simplify this, my final answer is going to be 9. Now, let's look at this one, but I'm going to go through this a little bit quicker. I'm still going to use the same colors for x and y. So anywhere there's an x, I put in 5 now. It's the same expression. It's just got different values for x and y. So I have 2. I get to an x, so I put a parenthesis. Squared plus 3, parenthesis, minus 5, parenthesis. And then I go back and fill in my values. So x is 5. So I have 1 there and 1 there, and then y is negative 4. So if I am doing my order of operations, I would do exponent first and get 2 times 25. Actually, I can leave that in parentheses. It doesn't matter if you use the bullet or the parentheses. It's going to give you the same thing. And then everything else I'm just leaving the same so that I can do my multiply step at the same time. So this would give me 50 plus negative 12 minus 25. And I went ahead and brought this plus down, but then 3 times 4 gave me the negative 12. So I have to combine those signs, and it would make it just be minus. You don't have to show that step. I just wanted to show my step for how I got that. So 15 minus 12 would give us 38, and 38 minus 25 would give us 13. And that would be our final answer. Now, another key thing that we need to know, or key vocabulary, is like terms. And we say that two terms are like terms if they have the same variables raised to the same power. So what does that mean? Here are a couple of examples. Notice here in the first one that our variable is t, and then the exponent of t is the same. If we had 4t to the 5th and negative 2, let's say it's x to the 5th, those variables are different. Those letters are different, so they would not be like terms. If I had t to the 4th, even though the t is the same, then the exponents are not the same. So this would not work. And that's why we would have to have the variable and the letter be this, or the letter and the exponent be the same. Here I can see I've got x to the 4th, x to the 4th, y to the 7th, y to the 7th, and then z and z. So they're the exact same things. The number in front is called the coefficient. And even though the coefficients are different in each case, that's okay. It doesn't matter as long as the variables are the same. So let's simplify by combining like terms. The first thing we're going to do here is distributive property. We're going to get negative 2x minus 2y to the 3rd plus 4x plus 7y to the 3rd. Notice I didn't change anything over here. I just wanted to distribute first. Now that I've gotten that taken care of, I can look for any like terms. And again, I like to use lines to show if things are like or not like. So for example, I've got x here. This is not a like term because x and y are different. But here I've got x. Both of these are x to the 1st, so those are like terms. Next I've got y to the 3rd. This is a y to the 3rd, so even though, again, those coefficients are different, the variable is raised to the same power, so they are, by definition, like terms. So I'm going to combine these. I'm going to combine the straight lines together. And if you want to write it out and show your work for this, it would look something like this. Negative 2x, and then I'm going to keep this sign, plus 4x. And then I'm going to say plus my squiggle lines, negative 2y to the 3rd plus 7y to the 3rd. So if I combine these, I'm going to get negative 2 plus 4 is positive 2, and I just keep the variable exactly the same. And then here, we're going to have negative 2 plus 7, which is positive 5y to the 3rd. That would be our final answer because x and y are different. These are not like terms. So on this one, I'm going to go ahead and do distributive property. Now, you might say, oh my gosh, a fraction, I can't do it. Guys, fractions are our friends. If we learn nothing else this year, I want us to learn that fractions are not that bad and that we are capable of working with them. So I'm going to do this. I'm going to keep the stuff on the left, first of all. And now I've got a -3/2 times 4. Well, if I think about it as 4 over 1, the 2 cancels with the 4, and that makes 2 and 1. And then I've got 3 times 2, which is 6. So 6x squared. Then I can do the same thing over here. If I distribute 3/2 to 2, the 2's actually end up canceling out, and I would just get 3. But I've got -3/2 and -2. If you need to put a parenthesis around that -3/2 to remind yourself that that negative goes with the 3/2, go for it. That would be a really great reminder for yourself. And then we are going to say negative times a negative is a positive. 3/2 times 2 we saw over here is 3. 3a. So I'm going to identify what are my like terms. I've got a squared. Well, that's squared, but it's x. Squared but x, so those aren't like terms. I've got an a, but it's not raised to the second power, so this one has no like terms. It's just going to come down here and hang out by itself. Then we have x squared and x squared. These are like terms, so I can do 9 minus 6, which gives me +3, and then I keep the variable the same. And then finally, we've got 3a. And you can make up whatever kind of lines you want. 3a did not have any like terms, so I just bring it down. The order that you're putting these in, I don't really mind right now. We'll talk in later units about standard form and how to write that. But for now, I just want to make sure that you're identifying correctly if things are like terms.